So today we'll be talking about the reversible reactions and the equilibrium. Okay, why equilibrium? Because I think this topic is quite confusing for students when they attempt a question because they don't know in which direction the equilibrium would shift. It's all about the shifting of equilibrium, whether it would move to right or it would move to left, and what are the different changes that are made during the reaction. Okay, do you know what principle do we follow when we talk about how to maintain an equilibrium? Okay, these are the factors. Okay, temperature, pressure, concentration. Exactly, concentration. So these three are the major one which are controlling the direction of a reaction. Okay. Before discussing the equilibrium, we should know about the exothermic reaction and the endothermic reaction. Because when we talk about temperature, we need to talk about the whether the heat is absorbed or it is released. Done? Okay. So what are exothermic reactions? So what do you think? If we increase the temperature, what would be effect on the equilibrium? If the heat is given out, already the temperature of the system is very high, but we are giving it more temperature, we are increasing the temperature, what would be effect? The temperature of surrounding would increase. Okay, okay, okay. So when we talk about equilibrium, let's first talk about the temperature. Okay, when we talk about the temperature, if something is already releasing heat, it means that system has no capacity to absorb more heat. So instead of moving in forward direction, that reaction would move in the reverse one. Okay, wait. If I'm explaining a reaction, for example, the preparation of ammonia, or we say the any exothermic burning of methane. Okay, combustion, it releases. Okay, what are the products of combustion? What are the products of combustion? Okay, every time when we talk about combustion, the products are same. Okay, so what do you think? If you're burning something, what would be produced? These are the reactants. What would be the products? Carbon dioxide and H2O. Exactly. So you know the answer. Okay. So it's carbon dioxide and water. So the products of combustions are same. Okay. But this reaction is not reversible. Okay. Combustion is not a reversible reaction. For example, if you're burning wood, you cannot reverse it. Okay. So these reactions are irreversible. Well, if we talk about the preparation of, for example, the sulfuric acid, that is a reversible reaction. The contact process. What are the 5 points of contact process? The pressure for contact process? Okay. Okay, okay, okay. Okay, what is the temperature? Okay. What is meant by ATM? Atmospheric pressure, okay. What would be temperature? It would be high. 400. Okay, what would be the catalyst? It's vanadium. Vanadium. And if we want to be more specific, it's vanadium pentoxide. Okay. What are the reactants that are required? Yes. What are the raw materials? That is your number four point. What is a raw material? Sulfuric acid. What else? Yes, sulfur oxygen. Yes, we add sulfuric acid to produce oleum, and from oleum, the sulfuric acid is produced. Okay, so I'm just writing the reaction. First of all, these two react to form SO2. This sulfur dioxide reacts with more oxygen and convert into sulfur trioxide. Now, this reaction is the reversible one. Okay. Yes, yes, we should know the reversible one especially, because these are part of reversible one. Okay, so if we say if we talk about this reversible reaction, this is the exothermic one. Okay, heat is given out. So if we increase the temperature, this would move in the reverse direction. It would form more sulfur dioxide and oxygen, because this reaction is exothermic. So if we talk about the temperature, let's say if we increase the temperature and we are applying it on something which is already exothermic, it will move in backward direction. Okay, this is for exothermic. What about increase in temperature for the endothermic reactions? Forward direction. Okay, so these are the basic things that we should know. What happened when we increase the temperature? What happened when we decrease the temperature? Okay, what happened to both if we are decreasing the temperature? If we are decreasing the temperature of exothermic reaction, equilibrium will shift to forward. And if we decrease the temperature for endothermic, it would move in reverse. Okay, correct. Forward for exo and reverse for endo. Okay, one more thing. Now, this is easy to explain. Now, if there is an MCQ, multiple choice question, it won't be like this. Multiple question would ask you what will happen to the equilibrium if you increase the temperature, or which reaction is favored by increase in temperature. Which reaction is favored by increase in temperature? Look at these statements and then tell me. Which, okay, which reaction, oh sorry, which reaction is favored by increase in temperature? Increase in temperature. Okay, how do you say favored? Favored का मतलब है more products are produced. Endothermic, exactly. एक और reaction है. I'm giving you a reaction. Just give me a minute. Okay, so now you have to tell me, because this is the question that is actually part of the past paper. So we have ICl plus chlorine. It gives iodine trichloride. Okay, this is a reversible reaction. Okay, what will happen if we heat it up? Yes, if we heat up. Okay, let me tell you delta H. uh, Delta H is negative, let's say. Okay, it means it is an exothermic reaction. Okay, if we increase the temperature, what will happen in the backward direction? Okay, correct. Clear? Okay, Let me apply pressure to this. Now we have discussed temperature. Next point is temperature. Okay, pressure. Whenever we talk about pressure on equilibrium, it's related to number of moles. Number of moles. How to calculate number of moles? In this equation. For this equation. I'm not asking about the formula that we use. For this equation, we have to add up the coefficients. Okay, it's 1 plus 1. So there are 2 moles on the left side and there is only 1 mole on the right side. Okay, okay, okay. It's a rule of maths as well, algebra as well, and chemistry as well, that if there is no number before some variable, it would be 1. Okay, like we consider every number has an exponent of 1. If it's not written, it's 1, it's obvious. So if nothing is written, it means it's 1. And you should know this because when you calculate delta H in the exothermic and endothermic reactions, then you have to keep in mind that this number is obvious, 1 would be there. Okay, okay, so there are 2 moles on the left side and there is 1 mole on the right side. They are unequal moles. Okay, when we increase the pressure, the equilibrium would shift to the direction which has lesser number of moles. Okay, when we increase pressure, it would move to lesser number of moles. Now tell me, what would be direction? Forward. And if we decrease the pressure, backward. So decreasing the pressure would shift the equilibrium to the direction which has more number of moles. It's inverse. Okay, okay. Number third thing is the concentration. Okay, let's talk about the concentration. This is 2, this is 1. Let's talk about the third one, the concentration. Okay, now you need to listen to me carefully. Now my product is formed, iodine trichloride is formed. Now I have extracted it. I've taken it out of the system. Now there is no ICl3 in the system. What would be direction of equilibrium? Taken out. Is taken out. Yes. Think carefully. You have to maintain the equilibrium. You have to. Okay. Yes. There's no ICl3. And okay. Towards the right because the quantity or the concentration should be same on left and right. If we decrease the concentration, it would move into in the like right direction, right direction. And if we increase the concentration of ICl3, then it would move in the reverse direction. Okay, increase in concentration moves to the okay. I'm talking about the concentration of product, not the reactant. When we talk about the reactant, if I increase the concentration of reactant, yeah, towards forward, yes, in the forward direction. And if I decrease the concentration of Cl2, only one, I've removed chlorine. What will happen then? I've taken it out of the system. I've taken it out. What will happen? It would move in the reverse direction to maintain the equilibrium so that there should be chlorine present in the system. Okay, if or in other case, if I have taken out ICl, iodine monochloride, then again it would shift in the backward direction so that they should be at equal level. All the components should be present in equal concentration. This is equilibrium. We have to maintain the equilibrium. Okay, what is the effect of catalyst on the equilibrium? Would it shift the, okay, what is the effect of catalyst? This is a question. What is the effect of catalyst on the equilibrium? Okay, it increases the rate of reaction. That is correct. What is the effect on equilibrium? It increases the rate of reaction, but it has no effect on the equilibrium. It won't shift it to right or left. Okay, so this part is also like sometimes got wrong. Okay, let's move to the question. I'm giving you one question. Let's move to the question. Okay, now let's discuss this statement. This is quite common question in CIs. Water and white solids are produced, let me tell you, when blue copper sulfate is heated. So copper sulfate is hydrated with 5 molecules. What is meant by water of hydration or water of crystallization? Water of crystallization. No, I'm just asking a general question. What is water of crystallization? Okay. Water of crystallization are the number of water molecules that get attached to the whatever compound during the alignment or during the formation of that molecule. They become part of that lattice. You must have done ionic bond, right? So mostly ionic compounds are in the form of lattice. What is lattice? Okay, so it's like a cube. Okay, so lattice is something in which the molecule, oh sorry, the ions are arranged in a particular geometry at a particular angle or length. Okay, is my screen visible? Okay, I don't think so. No, okay, because I've given a question. Um, where is the lesson? Okay, here is a meeting. फ्रान मेरा वन नोट नहीं चल रहा, मेरा सिस्टम ही नहीं चल रहा. हाँ, वन नोट हैंग हो गया. Okay. Uh, okay, so we have a reaction in which we have heated the blue thing, which is hydrated. Now we have heated it, that water molecule got removed and it turns from blue to white. Okay. Now we have added water in it. It again turned blue. What type of reaction is this? Would it be reversible or irreversible? Yeah, it would be reversible. Okay. And what type of reaction is this? Is the water being removed or added? Hydrated. So the answer would be D. Okay, good. Okay, let's move to the second question. Okay, let me ask it generally because we have only 5 minutes left. This all thing is called as the Lee Chatelier principle that you must know. Okay, I'm giving you one reaction. We have ammonia, we have nitrogen, and then we have hydrogen. Okay, can you write equation on your notebook? Because you need to send me the picture for this. Okay,